what is enough VDDQ package power integrity analysis with a DDR4 PHY. And the whole premise of this talk, it's a real world story that I wanted to share with a colleague. Another colleague and I actually worked on this. A colleague named Jim Kashevsky. He's a good friend and a great engineer. And we wanted to present the story about an experience where we went through, and we've been seeing this over and over. And this is a topic that's actually pretty near and dear to my heart, which is vendor models aren't always right. And what do you do?
Hi everyone, it's Judy Warner. Welcome back to this bonus edition of the Ecosystem Podcast. Today I'm joined by Ben Dannan, who is the owner of Signal Edge Solutions, as well as Principal Engineer and Technical Fellow at a large mil-aero contractor. He's going to talk about package PI analysis and how that can hurt you not only at the package level but across the whole system. I hope you enjoyed this teaser from his talk, and make sure you go into the show notes and sign up for EDI Con next week. Now let's jump into our conversation with Ben Dannan. Hi Ben, thanks so much for joining me again. It's always great to have you on, and I'm excited to learn about your EDI Con presentation that you're doing next week. But why don't we start off by having you just introduce yourself to our audience?
Hey, Judy. Thanks for having me back on. I always love being on your podcast. So, yeah, I'm a signal integrity and power integrity guru, I guess you could say. I love playing in this area. And so I get to work with folks like Steve Sandler and Heidi Barnes. I work at a big aerospace defense contractor, and I have my own LLC that just allows me to play and work with these folks, these amazing folks, and grow and learn and just do fun things in the field of signal integrity and power integrity. That's a good enough high level, right?
That's you in a nutshell. Yeah, we don't have enough time to talk about all the projects you're into, and you're an ex-military guy too,
I am.
from the reserve. So why don't you give him a quick story about that?
Oh, sure. Yeah, I was a combat system officer. So for those Top Gun fans out there, if you like Maverick, I'm Goose. So I'm the backseater. I was the guy telling the pilots, turn left, turn right. And pilots just looked at me and said, Nav. Sometimes we're just called Nav. I just want to know this. Trees get bigger, so stick goes down. Trees get bigger, stick goes up.
Just the facts, just the important stuff. Well, let's talk about, in regards to this power integrity expertise you've developed over the past several years, what are you going to be presenting at EDI Con? Because I don't even want to try to say the title of your talk. It's too long for me.
Sure. So it's on October 4th, and I think it's at 1:30 p.m. The title is, What is Enough? VDDQ package power integrity analysis with a DDR4 PHY. And the whole premise of this talk, it's a real world story that I wanted to share with a colleague. Another colleague and I actually worked on this. A colleague named Jim Kashevsky. He's a good friend and a great engineer. And we wanted to present the story about an experience where we went through, and we've been seeing this over and over. And this is a topic that's actually pretty near and dear to my heart, which is vendor models aren't always right. And what do you do? And it's already a big challenge today if you're trying to do an end-to-end power integrity analysis, and let alone with a full DDR power integrity analysis where you have multiple DRAM, you have your ASIC which has the DDR4 PHY, you have your package, your board effects, and your VRM model, and let alone these margins for the voltages are getting smaller and smaller. And so one more thing you have to worry about is just making sure your models are right. And so if your model is right, what do you do? Or isn't right, excuse me. If your model isn't right, what do you do? And so what if it's a die model? And so that's the whole premise of the story that we're going to share. It's going to be a lot of fun and really looking forward to it.
So first of all, so it was this project that made you sort of want to share this experience and this learning for people who are attending EDI Con, which, by the way, if you haven't heard me say before, it's online, and you can register and you can watch it live and get continuing ed credits, or you can watch the recording later. So what should engineers who join your session expect to learn, and why did you want to learn it?
Well, I love power integrity first and foremost. So this is my wheelhouse. And I think one of the things that we want folks to walk away with is that they need to trust and verify the models are going to use their vendors. Whether it's a capacitor or a die model, it doesn't matter. If you look at the IBIS forum, right, the IBIS standard, they actually have a quality report. And most folks may or may not know that. And it wasn't well known to me years ago, and it's been out for a while. And they actually are teaching folks to say, hey, if you're getting an IBIS model from a third-party vendor, ask for the quality report. And so if you're getting a die model, why shouldn't you get some sort of quality report to hold these vendors accountable? I mean, these are just as complex, if not more so, than any sort of IBIS model. And that's part of the gap in the industry. I mean, you go and pull a capacitor model from Murata or AVX, there's no standard on how they made that measurement. And
Yeah.
that's part of the problem, right? So being right matters, which is what one of a good friend of mine and a mentor says, Steve Sandler, and a friend of yours as well. And to be honest, having good models is where it starts.
Yeah. Which, yeah, I had Heidi and Steve on not long ago, and we definitely hammered on that pretty good. And of course, I smiled right away just then because I recognized your quotes from Steve. He's drilled them into my brain too. So, what kind of, without giving away your secret sauce or what you're going to show, like, yeah, so what do you do? How do you know if you have a good model? Like, what are some solutions you're going to offer and some things you have found that work for you?
Great question. And so some of the techniques we're going to show aren't, I wouldn't say there aren't, I would not say that they are new. You can find these in some great books by some other evangelists like Eric Bogatin and Larry Smith. In fact, we're actually referencing one of their books as part of this effort
Okay.
because it's right out of their book, but these things are easily forgotten and maybe you didn't think you could apply it in this manner. And so that's what we're showing in this talk. So in fact, we initially got the die model from a third-party vendor. And in most cases, people aren't going to design their own DDR4 PHY, right? They're going to integrate a PHY from somebody else because they have their own IP on the ASIC to worry about. But they have some
Right.
requirement to have some sort of memory. And so they're going to integrate this DDR4 PHY from a Cadence or Synopsys or somebody else. There's only a few vendors out there you can buy these from.
Mm-hmm.
And so in this instance, you have all this data coming in and it's hard to vet it until you need to use it. And what we show is initially the die model that we got from this vendor was not the right value, specifically the on-die capacitance or C-die. And we walked through the exercise even after I approached the vendor many times. I said, hey, so you guys know that C-die is way too low. They're like, no, that's right. I'm like, are you sure that's the right value? Because there are other die models for other memory controllers and it's way higher, like orders of magnitude higher. And they're like, no, that's right. I'm like, okay, so can you like maybe do like a manual calculation to show me what that C die should be? And it's really not that hard to do this because all you have to do is, look at the area of the caps that are on the grid and you know what your DK is because that's in the tech file. And you can calculate the on-die capacitance because epsilon times A over D equals the capacitance and multiply that by the total of capacitors on the grid. That should give you an approximate. And they're like, no, that's right. I said, okay, so they're going to really make me dive into this and prove it to them. And so that's part of the story that we're going to share on October 4th and walk everybody through this process of how we went from A to B, all the way to calculating what the minimum on-die capacitance needs to be using a technique right from Eric Bogatin and Larry Smith's book, to be honest. So it's not rocket science, but there's so much out there. The goal is to show folks a practical approach
Right.
and a way to use these methods while showing them how to do complex modeling of this nature.
Well, Eric, will be the first to tell you, is wise and guru that he is every book he writes is the practical guide to, right? So I'm sure he would love that you were citing that and making it practical. And also, I should mention to the audience that your talk's only like 25 minutes, right? So it's pretty easy to digest. Awesome. And then I think it'd be really, I like the way you're kind of serving up as a real life case study that you guys went through and will be so relatable. It's almost like a technology story, right? But seems really relatable than a bunch of
Yeah,
theory.
yeah. Yeah, I mean, we knew it was wrong from the get-go. Just going about proving it, right? We're all working for big companies and some bigger than others. And a big company like one of these, where they're in the billion, it's hard to break down those barriers. And so
Yeah.
if you're a smaller entity and you've bought some IP, how do you go about proving it? And that's the whole approach here that we're trying to show folks. So hopefully that's the takeaway. And they also walk away with, they need to hold their vendors accountable. Ask for some sort of quality report, right?
Mm-hmm.
Verification. Don't just take a model and willy-nilly just
Mm-hmm.
throw it in your simulation. Yeah.
So what I want to know is, did you go back to that vendor and say, no, it's not,
Oh,
and I
so
can prove it?
Yeah, so we proved it, and you know what they did? They came back and said, "Oh yeah, that's the wrong value we gave you." After we picked at it and we had schedule slip in our program, and so at that point we're like, "Okay, so what's the right value?" So they gave us a new die model, and we had calculated that the die model on die capacitance needs to be around 6.2 nanofarads. It was initially 3.29 nanofarads, so almost half what we calculated the minimum needed to be. And they came back and said, yeah, the actual value is like 6.49. So really close to what our calculated minimum was, like really close. So we dropped that into our model and we were failing their spec miserably, right? There's an AC voltage ripple spec that we were assessing at the die bumps on our package. And we were failing it by over 2x their limit with the initial die model of 3.29 nanofarads. As soon as we dropped it in, the new die model, we were passing, just barely, but we were passing. So it just shows you that what we calculated and what they gave us, that these methods are very practical and applicable to any sort of application like this.
Well, I was listening to an executive do a talk recently, and she was an executive like at Flex or something, like bigwig. And she was talking about some challenges they went through with COVID and having a global team and all that. But the one thing I took away that I thought, she goes, well, let's not just sit around and admire the problem. And I'm like, guy, don't we do that though? Like, yeah, it's those darn models, right? But I really love that you guys, sadly, your schedule slipped, but that you actually took the time to do it and bring it back. And like you said, hold the vendors accountable. And you actually didn't admire the problem or just fix it and go on. I think there was probably a good learning in it for you and the vendor. So
Yeah.
very cool.
Yeah.
Love it.
And there's some sanity check that we're going to show folks on how to do some basic sanity checking, right? That's part of this. I mean, we even showed a comparison to a Micron SDRAM, a by 16 SDRAM. And we showed, by the way, this is a great example. Every Micron SDRAM, they provide a quality report as part of their IBIS model and for their die model. And so this is what makes, the documentation from Micron so great. So why shouldn't you have the same level from any other vendor? And so we looked at the die model on die capacitance, and it's right there. It's more than double the initial value that we got from our IP vendor. And we showed that to this IP vendor and they're like, yeah, no, it's still right. And so just showing folks how to go through this method and apply this to get the right answer, I think that's probably the fulfilling part, to teach and help folks understand what to do if you're not getting the right answer from the vendor and how to prove it. Because these aren't easy to model, right? I mean, there's a lot of complexity in a model like this. You have 72 DQ nets, your strobe, your CAC, all running to toggle all those simultaneous switching nets, create that noise to get that overall response. And so it takes a lot of work to prove this to a vendor like one of these big guys.
Well, it's great that you did it, and I'm sure there'll be some really good takeaways. So, Ben, thanks so much for coming on and teasing up your class, and I'll definitely be there, and I'll call you later if I have questions, because I probably will. But sounds really great. Well, thanks again for coming on. Appreciate it.
Yeah, thanks, Judy, for having me. Always a pleasure.
So for our listeners and our audience, make sure you go. I'll put the links to EDI Con that you can go register there. It's free, and you can watch it online and get your continuing ed credits, or watch it, just register and they'll send you the recording later, but make sure you choose Ben's session. Thanks for being with us. Ben, we'll see you next time. And for our audience, we'll see you next week. Until then, remember to always stay connected to the ecosystem.